Welcome, cosmic explorers. Today, our journey takes us to the fourth planet of the solar system, a world that has captivated our imagination for centuries. Its striking red hue, enigma, and endless possibilities make it a subject of intrigue. Yes, we're talking about Mars. Imagine a world where colossal volcanoes rise 3 times taller than Mount Everest, where deep canyons could swallow the Grand Canyon whole, and where dust storms can blanket the entire planet for months at a time. Now, picture that in this very world, human-made robots are currently searching for signs of ancient life. Welcome to Mars, the planet that may hold the keys to our past and possibly our future. If the idea of exploring these Martian landscapes excites you, please give this video a like. And don't forget to subscribe to our channel, Exploring the Universe, for more interstellar adventures. Mars, often referred to as the Red Planet, has a rich place in ancient mythology. For the Romans, Mars was the god of war, symbolizing strength and aggression. The Greeks associated him with Ares, who represented chaos and conflict. This connection to war has influenced how cultures perceive Mars, often viewing it as a symbol of battle and conquest. Historically, Mars has fascinated astronomers since ancient times. The first detailed observations were made by Galileo Galilei in the early 17th century, who used one of the first telescopes to study the planet. His observations laid the groundwork for future explorations, revealing details about Mars that sparked curiosity and speculation about its nature. In fiction, Mars has served as a backdrop for countless stories. H.G. Wells' The War of the Worlds depicted a Martian invasion of Earth, capturing the public's imagination and fears about extraterrestrial life. Modern narratives have evolved to include themes of colonization and exploration, reflecting our growing interest in the possibility of human life on Mars. From films to books, Mars continues to inspire creative storytelling, serving as a canvas for our hopes and fears about the unknown. Mars is a fascinating planet, measuring about half the diameter of Earth. This smaller size contributes to its unique physical features and geological history. The planet's surface is rocky, composed mainly of iron oxide, which gives it its distinctive red color. Mars has a thin atmosphere, predominantly made up of carbon dioxide, with very little oxygen, making it inhospitable for human life as we know it. The gravity on Mars is approximately 38% that of Earth, which means that a person weighing 100 pounds on Earth would weigh only 38 pounds on Mars. This difference in gravity has significant implications for human exploration and potential colonization. A Martian day, known as a sol, is about 24 hours and 37 minutes long, making it quite similar to an Earth day. However, a year on Mars is considerably longer, lasting about 687 Earth days. This extended cycle affects the planet's seasons, which are reminiscent of those on Earth but last nearly twice as long. Understanding these physical characteristics is crucial as we continue to explore Mars and consider the possibilities for future human habitation. Mars is not just a distant planet, it is a key to understanding our own planet and the broader universe. Mars boasts some of the most remarkable geological features in our solar system. One of its standout landmarks is Olympus Mons, the largest volcano known to exist. Standing at about 13.6 miles, 22 kilometers, high, Olympus Mons is nearly 3 times the height of Mount Everest. Its massive shield structure was formed by successive lava flows, creating a broad, gently sloping profile that is a testament to Mars' volcanic history. The caldera at its summit is about 50 miles, 80 kilometers, wide, showcasing the immense power of volcanic activity on the planet. Another significant geographical feature is Valles Marineris, an extensive canyon system that stretches over 2,500 miles, 4,000 kilometers, across the Martian surface. To put this in perspective, if Valles Marineris were on Earth, it would extend from New York to California. This Grand Canyon system is not just a single canyon but rather a complex of interconnected canyons, some reaching depths of up to 7 miles, 11 kilometers. The formation of Valles Marineris is still a subject of research, with theories suggesting it may have been created by tectonic activity or erosion from ancient water flow. Mars is also home to polar ice caps composed of both water ice and dry ice, frozen carbon dioxide. These caps expand and contract with the changing seasons on Mars, revealing the dynamic climate of the planet. The northern polar cap is primarily made of water ice, while the southern cap contains a significant amount of dry ice. These ice caps are crucial for understanding Mars' climate and potential water reserves. The history of water on Mars is a central focus of research and exploration. There is substantial evidence suggesting that liquid water existed on the planet's surface in the past. Features such as ancient river valleys and deltas indicate that Mars once had flowing water, which could have supported a more temperate climate. The presence of these geological formations raises intriguing questions about the planet's ability to support life. Currently, scientists are investigating the search for water on Mars. Evidence of subsurface ice has been detected in various locations, indicating that water may still be present beneath the surface. In addition, seasonal dark streaks observed on some slopes, known as recurring slope lineae, suggest the potential for briny liquid water flows. These findings point to a more dynamic hydrological cycle than previously thought. The implications of water on Mars are profound. Understanding the history and current state of water on the planet is crucial for assessing its habitability, both in the past and for future human exploration. Discovering liquid water or its remnants would not only enhance our understanding of Mars' geological history, but also provide vital resources for potential human colonization. Water is essential for life as we know it, making Mars a focal point in the search for extraterrestrial life and the future of human exploration in our solar system. Mars has a unique atmosphere that significantly influences its climate and conditions on the surface. The atmosphere is composed of approximately 95% carbon dioxide, with trace amounts of nitrogen, argon, and oxygen. This high concentration of carbon dioxide contributes to a very weak greenhouse effect, which is insufficient to warm the planet significantly. As a result, Mars experiences extreme temperature variations. The atmospheric pressure on Mars is less than 1% of that found at sea level on Earth. This extremely low pressure means that liquid water cannot exist on the surface for extended periods. It either evaporates or freezes. The thin atmosphere also poses challenges for human exploration and habitation, as it provides little protection from harmful space radiation and meteor impacts. Temperatures on Mars can be harsh and vary dramatically. The average temperature hovers around -80 degrees Fahrenheit, -62 degrees Celsius, but it can range from a frigid -195 degrees Fahrenheit, -125 degrees Celsius, at the poles during winter to a relatively mild 70 degrees Fahrenheit, 20 degrees Celsius, near the equator during summer days. These fluctuations create a challenging environment for exploration, with equipment needing to withstand both extreme cold and occasional warmth. One of the most striking features of Martian weather is the global dust storms that can engulf the planet. These storms can last for weeks or even months, reducing visibility and significantly affecting temperatures by distributing dust particles throughout the atmosphere. During these storms, the planet can become nearly unobservable from orbit. The impact of dust storms on exploration missions is considerable, as they can disrupt communications, hinder solar power generation for rovers, and pose risks to landers and orbiters. If the idea of personally exploring these Martian landscapes makes your heart race, please give this video a like. And don't forget to subscribe to our channel, Exploring the Universe, for more interplanetary adventures. The exploration of Mars has a rich history marked by groundbreaking missions that have expanded our understanding of the planet. One of the first successful missions was Mariner 4, launched in 1964. This spacecraft made its closest approach to Mars in 1965, sending back the first images of the Martian surface. Mariner 4 revealed a cratered landscape, challenging previous perceptions of Mars as a lush, habitable world. Following Mariner 4, the Viking 1 and 2 missions in the 1970s were pivotal in Mars exploration. Viking 1, which landed in 1976, conducted experiments to search for signs of life, returning detailed images of the surface and data on the planet's atmosphere and soil. Viking 2 followed shortly after, providing additional insights into Martian geology and weather. These missions set the stage for future exploration and laid the groundwork for understanding Mars' potential for life. In more recent years, various rovers have played a critical role in Mars exploration. Sojourner, part of the Mars Pathfinder mission in 1997, was the first successful rover on Mars, demonstrating the feasibility of mobile exploration. This was followed by Spirit and Opportunity, twin rovers launched in 2003 that vastly expanded our knowledge of the Martian surface. Both rovers operated far beyond their expected lifetimes, with Opportunity exploring for nearly 15 years. The Curiosity rover, which landed in 2012, has been instrumental in assessing Mars' habitability. Equipped with advanced scientific instruments, Curiosity has discovered evidence of ancient water and organic molecules, enhancing our understanding of the planet's potential to support life. Most recently, the Perseverance rover landed in 2021, tasked with searching for signs of past life and collecting samples for future return to Earth. In addition to rovers, several orbiters are currently studying Mars from above. The Mars Reconnaissance Orbiter has been providing high-resolution images and data on Martian weather, geology, and surface changes since 2006. The MAVEN mission, launched in 2013, is investigating the Martian atmosphere and its escape to space. The ExoMars Trace Gas Orbiter, launched in 2016, focuses on detecting trace gases such as methane, which could indicate biological activity. A remarkable achievement in Mars exploration is the Ingenuity helicopter, which made history by performing the first powered flight in the atmosphere of another planet in April 2021. This small drone has demonstrated the potential for aerial exploration on Mars, providing a new perspective on the terrain and assisting rovers in navigation. The quest for life on Mars is one of the most compelling aspects of space exploration. Scientists focus on the concept of the habitable zone, which refers to regions around a star where conditions might be right for life as we know it. Mars is particularly interesting because it once had liquid water on its surface, which is a key ingredient for life. Evidence of organic compounds and methane in the Martian atmosphere has raised hopes for the existence of past or present life. Organic molecules, which are the building blocks of life, have been detected by rovers and orbiters, suggesting that the necessary ingredients for life were once present on Mars. Methane is especially intriguing because it can be produced biologically, and its seasonal fluctuations hint at ongoing processes that could involve microbial life. However, the search for biosignatures, indicators of past or present life, presents significant challenges. The Martian environment is harsh, with high radiation levels and extreme temperatures that can degrade organic materials. Additionally, distinguishing between biological and non-biological sources of methane is complex. As missions continue, scientists are working to develop more sensitive instruments to detect subtle signs of life, ultimately aiming to answer the profound question: did life ever exist on Mars? The ongoing exploration of Mars, driven by the search for life, not only enhances our understanding of the planet but also informs our knowledge of life's potential beyond Earth. Each mission brings us closer to uncovering the mysteries of the Red Planet and its possible role in the broader context of life in the universe. The relationship between Mars and Earth is a fascinating topic that has spurred scientific inquiry and speculation. One prominent theory suggests that there has been a transfer of material between the two planets, primarily via meteorite impacts. Over billions of years, asteroids and comets colliding with Mars could have ejected rocks into space, some of which eventually found their way to Earth. This exchange raises intriguing possibilities about the shared ingredients for life and the potential for microbial organisms to travel between planets. One compelling idea related to this exchange is panspermia, the hypothesis that life on Earth could have originated from microorganisms or biochemical compounds from Mars. Given that both planets share some similarities, including the presence of essential elements for life, proponents of this theory suggest that Martian rocks containing microbial life might have been propelled to Earth, seeding our planet with the building blocks of life. While this theory remains speculative, it encourages scientists to explore the connections between the two planets. When comparing the geological histories of Mars and Earth, both planets exhibit noteworthy similarities and differences. For instance, both have experienced volcanic activity, but while Earth remains geologically active, Mars volcanism has largely ceased. The geological features on Mars, such as ancient river valleys and lake beds, suggest that it once had a more Earth-like environment with running water. In contrast, Earth has undergone continuous geological processes, including plate tectonics, which have shaped its surface and climate over millions of years. Studying the geological histories of both planets helps scientists understand how they have evolved and what conditions may have allowed life to flourish on Earth while remaining elusive on Mars. Looking ahead, the future of Martian exploration is filled with exciting possibilities. One of the most anticipated missions is the Mars Sample Return Program, which aims to collect soil and rock samples from the Martian surface and return them to Earth for detailed analysis. This ambitious mission, a collaboration between NASA and the European Space Agency, will help scientists search for signs of past life and better understand the planet's geology and climate history. However, planning a crewed mission to Mars presents significant technological challenges. Engineers and scientists must develop reliable life support systems, radiation protection, and sustainable habitats to support astronauts during their long journey and extended stays on the Martian surface. The mission's complexity also involves ensuring safe transportation to and from Mars, which requires advancements in propulsion technology and spacecraft design. Another intriguing concept is terraforming, the idea of modifying Mars' environment to make it more Earth-like and potentially habitable for humans. This could involve various strategies, such as introducing greenhouse gases to thicken the atmosphere, warming the planet, and even creating bodies of liquid water. While terraforming remains largely theoretical, Discussions about its feasibility raise important ethical and scientific questions about our role as stewards of other planets. As we continue to explore Mars, each mission provides invaluable data that enhances our understanding of the red planet and its potential for supporting life. The future of Martian exploration holds the promise of not only answering fundamental questions about our neighboring planet, but also deepening our understanding of life's existence in the universe. As we conclude our exploration of Mars, it's essential to reflect on what this enigmatic planet represents for humanity. Mars serves as a mirror of our past, revealing clues about the conditions that may have once supported life. Its geological history provides insights into the evolution of our own planet, offering a glimpse into the processes that have shaped Earth over billions of years. In this way, Mars is not just a distant world, it is a canvas upon which we can understand our own origins and the broader narrative of life in the cosmos. Moreover, Mars acts as a laboratory for our future. The ongoing exploration of the red planet equips us with the knowledge and technology necessary to address fundamental questions about life beyond Earth. As we develop the capabilities to send humans to Mars, we are not just preparing for exploration, we are laying the groundwork for potential colonization and even terraforming. The lessons learned from Mars could guide humanity in preserving our own planet and ensuring our survival in the universe. As we reflect on these themes, we invite each of you to imagine the role you could play in the future of Martian exploration. Whether as a scientist, engineer, or enthusiastic supporter, your contributions can help shape the next chapter in our quest to uncover the mysteries of Mars. Each of us has a part to play in this exciting journey, whether through advocacy, education, or innovation. If this video has helped you see Mars not just as a red in the sky, but as a world brimming with mysteries and opportunities, please give it a like. Don't forget to subscribe to our channel, Exploring the Universe. Together, we will continue to unveil the secrets of the red planet and dream of the day when we might call it our second home.